Okay, I just wanted to make a video here to help you guys get started on some of this. I tried to do it on the computer and it just didn't really work out so well. So number 4, it says the half-life of rubidium-87 is about 48.8 billion years. And so if you write that out, that's what 48.8 billion looks like right here. And so if you're going to set this up using decay model, then I'm going to use y equals ae to the negative kt. And so there's really 2 ways to set this up. One way is to set it up using all the zeros, because half-life means half of it's left. The other way to set it up is if you don't want to write all the zeros out, you can just write 48.8, but know when you solve for time, your answer is going to be in billions of years. And so I'll show you the difference in that. Both of these, the same thing's going to happen. The a's are going to cancel out. We're going to ln both sides. And when I ln this side, all these zeros, the ln and the e cancel out. That's what we learned before break. So then I just get ln of 1/2 equals negative 48.8 billion k. Oh my gosh, Nolan. And so then I divide that over, and so I get k equals ln of 1/2 divided by negative 48.8 billion. Oh, I'm losing it, kids. So when I do that on the calculator, I get, let's see if I did the right amount of zeros. I get k equals 1.42038 times 10 to the negative 11th, because that's a really small number, okay? And I can type that in my calculator. I can use Desmos. If you do it the other way, it's the same thing. You end up with ln of 1/2 divided by negative 48.8. And you just get 0.0142038357. And notice it's the same decimals. It's just however many, like the way it's written is because I wrote it out all like this. So when you go to solve part B, if you use this number, your answer is going to be in years. If you use this number, your answer is going to be in billions of years. And so if you get like 0.7 as your answer, that's 0.7 billion, or that's the same as 7 million. Okay, so anyway, we'll look at that with answers. Also, number 5. I really like number 5. I like it much better than number 4 because the half-life is it's much easier way to do it. And it says a certain bacteria grows exponentially according to this model, y equals 80 e to the kt, where t is the time in minutes. So again, I'm going to help you on part A, and then I want you to try part B. It says if there's 80 cells initially, that's right here, and 675 cells after 30 minutes, that's going to go here. So 675 after 30 minutes, that's my time. So kind of just like the last one, only with much easier numbers here. I'm going to solve this, and I'm going to divide by 80. And I don't even simplify anymore because I just use my calculator. And I get ln of 675 over 80 equals e to the 30, ln of e to the 30k. The ln of e cancels out. So I get ln of 675 over 80 equals 30k. And then I divide by 30. So k equals this, which again, I'm going to type in my calculator, ln of 675 over 80, then divided by 30. Nolan, your game is way too loud. 0.071085 as my k value, which then you'll use for part B. So hopefully this will help you get started on the rest of your homework.